Hey guys, how's it going? Next one is 7-2, the Pythagorean Theorem and its converse. This is something we've sort of been working with all along with the distance formula. It's been disguised as the distance formula, but in essence we've been using the Pythagorean Theorem this entire time. Okay, so it's named after a Greek guy named Pythagoras. He was a Greek mathematician who lived in the 6th century BC. We know that the Babylonians, the Egyptians, and Chinese were aware of this relationship before its discovery by Pythagoras, so it's been around a long time. There are many proofs, and let's see, is number 60 in our exercises here? It's not, so you won't be proving this. That's alright. That can be saved for a later date. So let's go ahead and write it down. Theorem 7-4, the Pythagorean Theorem. Okay, and this says that in a right triangle, so you have to have a right triangle for this to work. C, B, and A. The sum of the squares of each of the legs is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. So I ran into an issue with the copier machine here. So it kind of goes out of order. The book wants to talk about Pythagorean triples really fast here. These are special triangles that have nice numbers. So a triple would be a set of non-zero whole numbers a, b, and c. They must be whole numbers that satisfy the equation. Here's some examples. A 3, 4, 5 triangle, so you'd have legs of length 3 and 4 and the hypotenuse 5. A 5, 12, 13 triangle, 8, 15, 17 triangle, and a 7, 24, 25 triangle. Okay, so for example, 3 squared is 9, 4 squared is 16, you add them together, you get 25. 25 is 5 squared. 5 squared is 25, 12 squared is 144, you add them together, you get 169, that's 13 squared. 8 squared is 64, 15 squared is 225, you add them together, you get 289, and that's 17 squared. And lastly, 7 squared is 49, 24 squared is 596, and 25 squared is 625. So you add these two together, you get 625, which is 25 squared. Alright, let's go ahead and flip the page and go to where it says example 1, Pythagorean triples. We want to find the length of the hypotenuse of the triangle ABC. Do the lengths of the sides of ABC form a Pythagorean triple? Okay, so find the length of the hypotenuse. So let's go ahead and do that. We're going to do 20 squared, so that's one of our sides, plus 21 squared. And that'll equal to the hypotenuse squared. So 20 squared is 400. That I believe is 442. Let me get a calculator. $441. That was close. And then we'll add those two together. That's 841. And then we'll take the square root of that number, and that's going to equal 29. So yeah, we do have a Pythagorean triple. So that's yes. And why? Well, it's because that's a whole number. Okay. So if you've got 3 whole numbers, then you're looking at a Pythagorean triple. Check understanding. A right triangle has a hypotenuse of length 25 and a side length of 10. Find the length of the other side. Do the lengths of the sides form a Pythagorean triple? So we've got a squared plus b squared equals c squared. The hypotenuse is 25, so we'll do 25 squared. One of the lengths is 10, and we're solving for that missing length there. So that's going to be 625 equals 100 plus b squared. So b squared equals 525. So I'll take the square root of that number, and that's not a nice number. It says in some cases you'll write the length of a side in simplest radical form. So if I did the radical of this, let's see, can I take out a 25? Yeah, I can. So this would actually equal 5 times the square root of 21. In your calculator, if you did this, it was 22.91. This is not a Pythagorean triple because all three are not a whole number. Alright, using simplest radical form. So find the value of x, leave your answer in simplest radical form. Radical forms means that we're going to have a square root in the answer. So our hypotenuse is 20. Okay, so let's go ahead and write that. 20 squared equals 8 squared plus x squared. So we're using the Pythagorean theorem again here. So that'd be 400 equals 64 plus x squared. Minus the 64, that's 336 equals x squared. Okay, and then I want to square root that. Let's see if that'll be a nice number. It's not. It's 18.33. However, let me see if I can pull out some numbers here. So what I'm going to do is I'm going to make a factor tree. Let's see, do I want to do that? Sure. I'm going to take out 2. So I'm taking out a 2 because any even number you can just take out a 2, because 2 goes into any even number. When you do that, you get 2 times 168. That's even again, so I can take out another 2. That'll be 84. It's another even number. So that's going to be 84 divided by 2. That's 42. That's another even number. So that reduces all the way down to 2 times 2 times 2 times 2 times 21. Okay, which is 2 times 2 times 2 times 2 times 21. That's the square root of 336. 2 times 2 times 2 times 2 is 16. And if you have inside your square root a square, I can take it out. So this is equal to, what's the square root of 16? It's 4 times the square root of 21. So x equals 4 root 21. That would be your simplest radical form. 21 does not come out nicely. There's no squares in it. So what you're doing is you're looking for squares. Okay, that's example 2. Let's move on to example 3 here. Recreation. The Parks Department rents paddle boards at docks near each entrance to the park. About how far is it to paddle from one dock to the other? So here's our docks. So what we're doing is we're going to use the Pythagorean theorem to solve for the hypotenuse since we have our legs. So I'll do 350 squared plus 250 squared equals c squared, which would be the square of the distance from one dock to another. So 350 squared, that's going to be a large number. It's 122,500 plus 250 squared. That's 62,500 equals c squared. And then I will add these two numbers together. I get 185,000 equals c squared. And it says about how far, so that's a clue that we can use a decimal. So c is equal to about 430 meters. I'm not including decimals because decimals were not given. So think of sig figs from science. What when you want to know how far you have to paddle a boat, why is an approximate answer more useful than an answer in simplest radical form? Because, well, I know about what 300 meters looks like. I know about what 400 meters looks like. It's a lot harder to think, what does 4 times the square root of 18 meters look like? I don't know. We don't measure things in that weirdness. So that's why it would be easier just to use an approximation. Okay, that, I believe, now we're going back to the first page. So this is example 4. Yeah. Finding area. We want to find the area of a triangle. So if you remember, a triangle is going to be 1/2 base times height, where height is in altitude, so you need that right angle. Okay, so it says here the large triangle is an isosceles triangle, so each side is the same length. The altitude is the base. The altitude to the base bisects the base and forms 2 right triangles. So you can use the Pythagorean theorem with the triangle at the right to find the height of the large triangle. Okay, I see. Okay, so we want to find this height here. We have a hypotenuse. If you're confused about how to recognize a hypotenuse, it is always going to be the side that's opposite the right angle. So here's our right angle. The side that's opposite is going to be the longest side possible. So let's do 12 squared equals 10 squared plus h squared. This is c squared equals a squared plus b squared, using the formula. So that'll be 144 equals 100 plus h squared. 44 equals h squared. And then, let's see, it's always useful to put this in simplest radical form. So let's go ahead and do that. 44 is 4 times 11. So h is equal to the square root of 4 times 11. 4 is a square, so I can take that out. 4 squared is 2. So h equals 2 times the square root of 11. And then once I have this, so this is h, I can plug this into my area formula, 1/2 base times height. So area is going to equal 1/2 times 20 times 2 times root 11. You can plug this part in a calculator. I have 1/2 times 2 basically, so those cancel. So my area is equal to 20 times the square root of 11 meters squared. Alright, I'm going to stop the video and then we'll cover objective 2 in the second video.